Hey everybody, how's it going? In this video, we're going to discuss two peripherals on PIC and AVR microcontrollers that I find pretty cool. These peripherals have the ability to function as customizable logic gates. They are called the Configurable Logic Cell, or CCL for short, on PIC microcontrollers, and the Configurable Custom Logic Peripheral, or CCL for short, on AVR microcontrollers. If you wanted to implement digital logic within your own application without these peripherals, you can do this in a couple of ways. The first way is through running software to make decisions within your application. You could write something simple like if push button value equals 1 and PWM output equals 1, then do something. Although this may not seem like a lot of code to make a decision, using software for decision making can have some downsides. The first is that you have a chance of missing your conditional statement. Let's say that we check this condition at the beginning of our while loop. Then, after the check, we do something else in code. If the user presses the button while the other lines of code are being executed, we will miss out on our conditional statement. And depending on the application, a missed conditional statement could be catastrophic. Now, before you say it, I already know what you're going to say. Ricky, I just generated an interrupt when the button's pressed. That way, no matter where we are in code, our MCU will be able to react. You viewers are so quick-witted, well done. However, although this is a decent solution, as you might have guessed, I have some reasoning as to why this might not work for all situations. The problem with generating an interrupt is that your CPU can no longer focus on whatever task it was doing before that interrupt. The brain of a CPU can only execute one line of code at a time. Therefore, as soon as you have an interrupt within your application, whatever your CPU was doing previously is now halted until the interrupt is fully serviced. If any of your application's code needs to run without being halted, then using interrupts is not an optional solution. On top of that, if you're working within a battery application, completely relying on software for decision making means that your CPU can never go to sleep or stop executing code. This for you means increased power consumption, which also means charging or changing batteries more often. Okay. So running software to make logic decisions has its flaws, but hey, why don't we just add some external logic gates to our application and boom, it's the perfect solution, sort of. Although we're now taking the decision-making workload away from our microcontroller, we've added external components to our application, which increases BOM cost. Not only did we increase the BOM cost, but these external logic gates have increased our application size as well. Dang it! Just when I thought we had it, if only there was another solution. The Configurable Logic Cell on PIC microcontrollers and the Configurable Custom Logic Peripheral on AVR microcontrollers gives you the ability to create custom logic through hardware-based peripherals that already exist on your microcontroller. Who wants to see how it works? Yeah! Let's start with the Configurable Custom Logic Peripheral, or CLC for short, on AVR microcontrollers. With the CCL, you have the ability to implement combinational or sequential logic without needing external hardware. For example, if I needed to take an output of an I/O pin and AND it with a PWM signal like we did in our software-based example, I can do exactly that. As mentioned before, if I need to add sequential logic to my CCL, I can do that as well. I can then feed the result of this logic operation to another I/O pin or feed it to another peripheral. Now I know this peripheral already sounds pretty cool, but wait, there's more. Not only can you add combinational and sequential logic, but you can also define the logic values of your CCL through a customizable truth table. One way you can do this is by giving the CCL an equation. As you can see, when I enter my equation, the values of the truth table change. Now my CCL's behavior will reflect that of the given equation. But don't worry, if equations scare you like they scare me, the CCL still has you covered. Another way to customize your truth table is through manually entering the values to the truth table. All that you have to do is tell the truth table what conditions should produce what outputs. As you can see, when I modify the output values of my truth table, the hex value changes as well. Again, my configurable custom logic peripheral will now behave based on my truth table. Similar to the configurable custom logic peripheral on AVR devices, the configurable logic cell, or CLC for short, exists on PIC microcontrollers as well. With this peripheral, you are able to add combinational and sequential logic just by selecting from this drop-down menu. You can also configure the inputs of the CLC to come from the outputs of other peripherals as well. Additionally, most PIC microcontrollers come with multiple CLCs. Therefore, multiple CLCs can be daisy-chained together to make a more complex logic peripheral. Another cool feature is that the output of the CLC can be routed to almost any pin on the microcontroller using the peripheral pin select feature. Not to mention the fact that the output of the CLC can then be fed to other peripherals as well. This gives you extreme flexibility when it comes to signal routing and peripheral triggering. What more could you ask for? Through the use of the CLC and CCL on PIC and AVR microcontrollers, you can now implement logic and decision-making within your application without relying on software or external hardware. This means for you, more reliable logic operation, a smaller application size, and a reduced BOM cost. For more information about the Configurable Logic cell and the Configurable Custom Logic peripheral, please view the CLC and CCL peripheral page linked in the description below. Also, be sure to click the like and subscribe button if you enjoyed this video. And as always, thanks for watching. See you next time.